everybody, good morning. So today is September 11th. So we're slightly behind schedule. So today we still continue on session 3.1. And then on Wednesday, we will start 3.2. Okay, so make sure you have the 3.2 handout on Wednesday. Okay. And this Friday, we have our second homework due, and we will have quiz 1. So quiz 1 is going to be about homework 1 and homework 2 stuff. Okay, so how are your homework? Doing well on your homework? Questions?
Will the quiz be at the beginning or the end of class?
Oh, it's online.
This is online.
It's online.
Oh, it's online.
Yeah, in Blackboard. So
exams are in class.
yeah, exam are in class. Right. So
And with the quiz, we have to take a picture at the end of any work we do, and then submit that.
yes.
Okay.
So yeah, the picture, because usually it's just one page, so you don't have to convert into a PDF. So you just the picture and then upload it in Blackboard. So yes, on a Friday you will be able to see the quizzes. So this is a quiz, okay? So it's hidden right now, but after like the midnight, okay, the 12 a.m. midnight on Friday, you'll be able to see the quiz 1. And then you have the whole day, 24 hours to start the quiz. Once you start it, you must submit within 30 minutes. So you click the quiz. So you click this PDF, you can see the quiz questions. Okay, and then you write down your answers on your notebook. Please show all your stats. So not like your homework. Your homework you only need to write down the final answers, right? Your quiz show all your work, like the way how I show you in class. Okay, because each problem like at some point, and every step has points. If you only tell me the final answer, okay. For example, that problem to ask you to find the vertical asymptote. If you only tell me the vertical asymptote is blah blah blah, you might only get 1 point out of 5. Okay, so you need to show all your steps. Okay, factor, right, and then find a domain which is your denominator not equal to 0, and then on those numbers you compute the limits, the right side of limit. If you get infinity or minus infinity, then you have a vertical asymptote. If you get a number, then you have to go back and erase the plus sign. Remember, to show there's no vertical asymptote, you must show the two set of limits exist. Okay? And then you can conclude the vertical asymptote is blah, blah, blah. Okay, so every step has points. Make sure you look at our in-class notes. Okay, you review your notes before you take the quiz. So when you take the quiz, try to show all your work.
Is it okay if like we skip like a small step, small like writing down the step? We write down like the equation itself, but then straight from that we go ahead and write down what each part of the fraction equals, and then instead of like writing out all of it.
I would say as long as you get the main steps,
Okay.
then the calculation in the middle, it's kind of okay to skip
Okay.
1 or 2 ranks. At least, so I just want to see your thinking process. And so yes.
How many questions are on the quiz?
Usually 1 or 2. So if it's very complicated, then 1 question. But usually 2. Usually in class it takes about 15 minutes to take the quiz. But because it's online, you might need time to take pictures and upload it to Blackboard. So I give you 30 minutes. But it shouldn't take that long, okay? And a question? Oh, okay. If the window closed, sometimes accident happens. If the window closed, please open the second attempt right away and submit your work. So I set the setting to be unlimited attempts. But if you use more than 1 attempt, please email me and tell me what's going on. Okay? Yes.
Oh yeah. So for the second attempt, would it still be like the 30-minute time?
Yeah.
Okay.
Yeah.
Okay. Will it run on the same time slot that it did for the first quiz? Like say if I messed up or something on the first quiz, I wanted to retake it again, and it said I had like really restart. Like the time?
Yeah, the time will start.
Okay.
Of course, I want
I
you
just have
to
to
submit
email
as soon as possible.
Gotcha.
Yeah, yes. You're welcome. Okay, yes. So, do you see here browse local files? You just upload your picture here. Okay? And as Sean recommend you to use your laptop to open the quiz. Because I heard students, when they use the phone, when they open the quiz, and when they take pictures, the quiz got locked out. So use your laptop, and then you can email yourself the picture, and then upload your picture using your laptop. Okay? All right. So that's the quiz. All right. So today, let's continue on session 3.1. Okay. All right. So last time we talked about horizontal asymptotes and vertical asymptotes. Vertical asymptote is your x approaching to a finite number, but your y goes to infinity or minus infinity. Remember, everybody? And horizontal asymptote is when your x goes to minus infinity, your y approach to a number. Or when your x goes to positive infinity, your y approach to a number. Right, everybody? So last time we did a comparison of the vertical asymptote and horizontal asymptote in terms of the number and whether you can cross the asymptote as vertical line, horizontal line, or the limits. Okay? And we also compare like the step how to find vertical asymptote and horizontal asymptote. Vertical asymptote, you need to factor, right? Everybody, you need to factor the numerator and denominator and see if you have some bad guy and cancel it. But for horizontal asymptote, you're looking at the dominant terms. Okay? So in the Excel, make sure you write DTN and DTD for dominant term of numerator and dominant term of denominator. Okay? So after you write those down, then your limit is equal to the limit of, you just consider the dominant terms. Okay? This is like the shortcut proof. I showed you last time the formal proof, right? You divide the numerator, the denominator by the highest power, and then you end up getting something like constant over infinity, so that term goes to 0. Okay, that's the idea why those lower terms will goes to 0. Okay, so we only need to look at the dominant terms. And then example 2. Last time we did example 2. Do you see, because this problem we have the square root of x squared, that gives us absolute value of x. And when we break the absolute value, it depends on whether x is positive or negative. You will get different answers. So let's put a weight mark here. A remark. If you see square root of x to the even power, you might get 2 horizontal asymptotes. Okay, so write it down. Okay, so when you see square root of x to the even power, then you might get 2 horizontal asymptotes. Is that okay, everybody? Because x to the even power, when you take square root, is absolute value of x and then to the some power. Okay, for example, if you have x to the 10, you take square root. This is what? X to the absolute value to the, square root is half, right? So 10 over 2 is 5. Okay, but it's absolute value of x to the 5th. Keep that in mind. All right, let's continue to look at the and behaviors. So infinite limits at infinity. So if f of x becomes arbitrarily large, as x becomes arbitrarily large, we write limit x goes to infinity, f of x equals infinity. Okay. So let's draw the picture. So this is like, okay, x goes to infinity, and the y also goes to infinity. Right, everybody? You know, x goes to infinity is to the right. Y goes to infinity is the top. Right? And then similarly this, x goes to infinity, left or right? Infinity, left or right?
Right.
Right. And y goes to minus infinity, top or bottom? Bottom, right? How about this? Left or right? Left, top or bottom? Top. This one? Left, bottom. Exactly, right, everybody? So you can draw pictures of those. Okay, good. Now let's look at the end behavior of different functions. First, polynomial. So let p of x be a polynomial and n is the degree of the polynomial, right? And an is the leading coefficient. The leading coefficient is not 0. Okay, let's look at the following. If n is odd, and a sub n, the leading coefficient, is positive. Okay, let's use example to help us to figure out. N is odd. Okay, 3 is odd. Do you agree? Yeah, 3 is odd. And let's consider the function y equals x cubed. Do you see the n is 3, 3 is odd, right? The an is the coefficient, is 1, is positive. Do you agree? What's a picture of x cubed? Yeah, like that, everybody? So, let's draw the picture like that. Oh, do you see when x goes to infinity? What happens to the y? Top. Positive infinity. And when x goes to minus infinity, your y goes to bottom, negative infinity. See? You think about one example and then you can figure out the end behavior. Okay, everybody? So for all the R power and all the positive leading coefficients, it's kind of a similar picture, right? So end behavior will be the same. Okay, next. If n is r and a sub n is negative, well, think about y equals negative x cubed. Right, everybody? Your leading coefficient is -1, is negative. And do you remember if you put a minus sign in front of a function, this is like refraction over the x-axis. Yeah, so you flip it instead of that, it's going to be that. Right? So let's draw a picture. So like that. Now, do you see when x goes to infinity, what happens to your y? Negative infinity. When x goes to negative infinity, what happens to your y? Positive infinity. Yes, everybody? Okay, good. Next one. If n is even and a sub n is positive, give me an example. Even power is x squared. Exactly. What does x squared look like? Yeah. Right. You say, right? So, therefore, no matter x goes to negative infinity or positive infinity, your y goes to infinity. Okay? How about this? Give me an example. N is even and a sub n is negative. Give me an example. The upside down problem, minus x squared, right? So therefore it goes like this, upside down parabola, open set. Therefore, no matter x goes to infinity or minus infinity, the y goes to minus infinity. So far, so good, everybody? Yeah, use example to help us to understand and remember it. Okay. In any of those cases, we don't have horizontal asymptote because we're not approaching to a finite number, right? So we go to infinity or minus infinity. So no horizontal asymptotes. And furthermore, no vertical asymptotes. Okay, everybody? Polynomials continuous everywhere, is defined everywhere, so no vertical asymptotes. Okay? Continue, rational functions. So for rational function, you have the numerator and you have the denominator. Okay, let's look at this. Here, m is the power, the degree of the numerator. N is the degree of the denominator. If the denominator is bigger, okay, if the denominator is bigger, let's use some example to help us figure that out. Denominator is bigger. So you can think of numerator is like x, denominator is like x squared. Do you agree? In this case, denominator is bigger. Oh, do you see your x can cancel a copy? You get 1 over x, right? And when x goes to infinity, 1 over infinity is 0. Right, everybody? 1 over infinity is 0. 1 over minus infinity is also 0. 1 over 0 plus is positive infinity. 1 over 0 minus is minus infinity. Are you okay with all of these? Yes? So that's why, if our denominator is bigger, the limit goes to 0. Which makes sense. Your denominator is getting bigger, bigger, bigger. So your number is getting smaller, smaller, smaller. Right, everybody? That's why it goes to 0. Okay, next. If they're the same power. Oh, if they're the same power. Look at this. Like 2x squared over 3x squared. If they're the same power, do you see the x squared cancel? You just get 2/3. You get a number, right? That number is actually the ratio of the leading coefficients of numerator and denominator. Right, everybody? Okay. If the numerator is bigger. Oh. If numerator is bigger, like x squared over x, they cancel one copy of x, you still have an x left. Do you agree? Ooh, when x goes to infinity, the x goes to infinity, right? So your limit will be infinity or minus infinity. In this case, no horizontal asymptotes. Okay, everybody? Okay, so that's why the first case, the limit is 0. So the horizontal asymptote is the horizontal line, y equals 0. And in this case, it's approaching to this number, then the horizontal asymptote is y equals to this number, right? And if your numerator is bigger, it just goes to infinity or minus infinity. So no horizontal asymptote. Okay, everybody? Assuming that f of x is in the reduced form, p and q share no common factors, then vertical asymptote occurs at the 0 of the denominator. Do you remember when we find vertical asymptote of a rational function? We factor it, right? So you cancel the factors, then you get the lowest form. The lowest form will ever make the denominator 0. That's going to be your vertical asymptote. Okay, everybody? Yes. So this is what it says. Okay, good. Let's keep going. Exponential function and logarithmic function. Exponential function, like this. Right, everybody? Do you remember e to the x looks like this? And it passes through 0, 1, right? And the domain is all real numbers. But the range is only positive numbers. E to the x is always positive, right? So, therefore, limit x goes to infinity is infinity. When x goes to minus infinity, do you see we approach to 0? Yes? So that's why the horizontal asymptote is y equals to 0. And we don't have vertical asymptotes. So no vertical asymptotes in this case. Okay? And how about e to the minus x? Well, e to the minus x is just reflection about the y-axis. If you put a minus sign in front of x, then it's going to be a reflection over the y-axis. So you see, when x goes to infinity, e to the minus x goes to 0. And when x goes to minus infinity, it goes to infinity. Is that okay, everybody? Mm-hmm. Again, no vertical asymptote. And natural log of x. Do you remember natural log of x? It's the inverse function of e to the x. And the property of inverse function, the mirror image about the line y equals x. Right, everybody? Do you still remember that? Mm-hmm. That's why the picture of natural log of x looks like this. And it passed through the point 1, 0. Mm-hmm. The domain. Remember the domain for a natural log of x? All positive numbers. The range are real numbers. So in this case, when x goes to infinity, natural log of x goes to infinity. When x goes to 0 from the right, the y goes to minus infinity. Therefore, we have vertical asymptotes here, but no horizontal asymptotes. But we have a vertical asymptote at x equals to 0. Is that okay, everybody? Okay, that's exponential function and log functions. We continue. How about trig functions? You know sine and cosine like this? So they don't have vertical asymptotes. They define everywhere. And when x goes to infinity or minus infinity, the limit does not exist because it's oscillating between minus 1 and 1. So the limit does not exist. Okay? So therefore, no horizontal asymptote. And the tangent is a lot of copy of this, cotangent, a lot of copy of those, right? And we have vertical asymptotes. So we don't have any horizontal asymptotes. The limit at infinity is just does not exist. Okay? Similarly with secant and cosecant. So up, down, right? Then they have vertical asymptotes. And this is a vertical asymptote operation. So when you draw the picture, then you can figure out the vertical asymptote. Okay, everybody? Mm-hmm. All right. Okay, so good. Now let's look at example. All right. So to find horizontal asymptotes, what's your step? Look at your steps from the previous page. What's the first step when you see you want to find horizontal asymptotes? Factor? Yeah, DDN and DDD. Right? Factor is for the vertical asymptotes. Right, everybody? So dominant terms, only dominant terms, we care about it. Okay, so dominant term of numerator. Okay, any guess what it is? Oh yes, very good. Because this is a multiplication, right? So you need to consider this highest term of this factor and multiply by the highest term of this factor, right? Because it's a multiplication. So is 10x squared times 3x. That's very good. 30x cubed. Right, everybody? Okay, next. Dominant term of denominator. What is it? Dominant term of denominator. 25x to the 6. Is that right? We need square root. Yes, very good. Be careful, be careful. We have the square root, so don't forget the square root. Okay, everybody? What's square root of 25? 5. And what's square root of x to the 6? So this is 5. Square root of x to the 6 is x to the 3rd. But with what? If you see square root of x to the even power, what do you get? Absolute value. Okay. The square root is like to the 1/2, right? The 6 times 1/2 is 3. It's 3. But if you see square root of x to the even power, please make sure you put absolute value. Because in this case, you will have 2 different horizontal axes. Okay, everybody? Yes. All right, so how do we break it? Yes. No. A square root of x to the 6 is x to the 6 to the 1/2. And then it's x to the 6 over 2. Yes. Then that equals x cubed. But you actually need an absolute value of it. So it's not square root of 6. It's to the 1/2. Right, everybody? Yes, the nth roots. Okay. So because it's absolute value, we need to break it. So how do we break it? If x is greater or equal to 0, the absolute value of x is just x. Right, everybody? We just get 5x cubed. But if x is negative, what do we get? The negative, right? We get absolute value of x is negative x. That's why negative x cubed is negative x cubed. Here, be careful, everybody. So be careful, everybody. Here, if you have absolute value of x to the 4th, this is the same as x to the 4th. Is that okay, everybody? Because x to the 4th is always positive. Okay? It's just when your power is odd, then you need to separate into cases. Okay? Because our power, it can be positive. But for even power, they're always positive. Meaning greater or equal to 0. Right? Okay. Good. So now we see when x goes to infinity. And we get what? The numerator, 30x cubed. How about the denominator? Blank. Yes. Okay, what is the limit, William? Yeah, we cancel out x cubed, and 30 over 5 is 6. Right? On the other hand, when x goes to minus infinity, what do we get? Dylan? Yes. And what do we get? Yes. So we say horizontal asymptotes are, can we just say 6 and minus x? No. Is x equals or y equals? Horizontal line. X equals y, or y equals.
So we get 2 horizontal asymptotes. So far, so good, everybody? Okay, now it's your turn to do example 4. Okay, everybody do example 4. What is the Jonathan term? Yes, very good. Which one is it? In the exam,
Okay.
And so you answer what's the horizontal here equals to x. You can have simplify further. Oh, don't forget the minus sign. Okay, we'll do this. So, you look at this. Yes, good. Okay, let's check our answers. So we have the dominant term of the numerator is the negative square root of x. Square root is bigger than cube root. Okay, because the power cube root is 1/3, square root is 1/2. 1/2 is bigger than 1/3. Right, everybody? Mm-hmm. And the denominator is minus 9 square root of x. And that's it. Do not simplify. We cannot simplify further. The last example we can simplify further because we have x to the 6th inside. And 6/2, you get 3, right? But here we only get x. So this is the simplest form. We cannot simplify further. Okay, everybody? Mm-hmm. So that's why when x goes to infinity, just look at the dominant term of numerator and denominator. We get 1/9. But when you try to make x goes to minus infinity, look at square root. The square root, the x can only be positive or 0. You don't have the chance to go to minus infinity, so you don't need to consider this. So the horizontal asymptote is y equals 1/9. And that's it. Okay? So for this problem. All right. Let's see. Okay. Next one, let's go to example 6 because example 6 is harder than example 5. Let's do 6 together and then you do example 5. Okay, so example 6. We want to sketch a possible graph of function f such that it satisfies all of the given conditions. Be sure to sketch all vertical asymptotes and horizontal asymptotes if there are any. Okay, so draw a long line, that's the x, and draw a vertical line, that's the y. And we know 0 is in the origin. Okay, so when you draw this picture, try to make your picture clean. Don't put so many bars there. Okay, just put the one as needed. Is that okay, everybody? And you just want to sketch the picture so you don't have to make sure it's really the same scale. Okay? So let's look at the first one. X goes to minus infinity, left or right? Left. Right? X goes to minus infinity. My y goes to 3. So my y equals to 3, and then my x goes to minus infinity, right? So we have a horizontal asymptote there. So let's say this is 3. You put some dashed line to indicate this is a horizontal asymptote, and we're approaching it. But you're not sure we're gonna approaching it from the left, means from the top or from the bottom. So we're not sure. This information, let's put a pair of dots here. Okay, we will choose which one to see which one makes more sense. Okay, that's the first information. Okay, when x goes to minus infinity, the y goes to 3. So we're approaching it either from the top or bottom, so we're not sure at this moment. Let's see, next one. F of minus 3 equals 1. So minus 3 is kind of here, right? X is negative 3, y is 1, kind of this point, right? So let's label it. So minus 3 is kind of like here, 1 is like here. So we have a point here. Is that okay, everybody? So put the dots. And next one. When x goes to minus 2 from the left or right? Left. The y goes to minus infinity. Top or bottom? Bottom. Okay.
Okay, where's -2? Kind of like here. So -2, kind of like here. And we have a vertical asymptote here. So draw dashed line to indicate we have a vertical asymptote. And tell me again, it's left or right? Left, top or bottom? Bottom. So it's left side, bottom. Yeah, everybody? Put a little dot here to indicate it's left, bottom. Put a very little dot close to the line. Is that okay, everybody? And then when x goes to -2 from the right side, the y goes to -infinity, top or bottom? Still bottom. So it's from the right side and bottom, right? You put a little dot here as well. So put a little dot here as well. Okay, everybody? We want to put on the dot and we connect the dots at the end. Okay, next one. 1. 1 is on the right side of the 0, right? That's 1. And left or right? Left. And this is bottom. Okay, figure out the 1 here and draw a dashed line to indicate there is a vertical asymptote. We say left, bottom. So put a little dot here. So far, so good. Next, this one, left or right? Right, top or bottom? Top. So the right side of 1 and top, you put a little dot here. Okay? Put a little dot here. Okay. Keep going. F of 5 equals -2. You know, 5 is kind of like here. Do you agree? -2, kind of like here. Is that okay, everybody? So for other important points, just label the number. And you want your graph to be very clean, so you don't draw too many lines there. Okay, it will confuse you. So this is the number, yeah, f of 5 is -2. And then when x goes to infinity, that's the right, and y goes to -1. Okay, so we have a horizontal asymptote there. And we don't know how to approach it. Maybe the top or maybe the bottom. Let's put a pair of dots there. Okay, everybody? So for horizontal asymptote, because you don't know how to approach it, put a pair of dots. But for vertical asymptote, you know 4 directions. Left or right? Yes. Top or bottom? So there are 4. Okay, so you can put one dot. Now, let's connect all the dots together. And let's do it from the center, okay? Alright, let's see. Look at this one. So we connect this dot with this dot. Okay, tell me, the top one or the bottom one makes more sense? The bottom one makes more sense. Okay, so we connect the bottom one and erase the top one. Because you want a function, right? You want a function. So it must pass through the vertical line test. You cannot have like one input give you 2 output. That's not allowed. Okay. And next one. Oh, do you see we have these 2 points? And when you connect them, can you do this? No, you cannot do that. So you have to be something very smooth. Okay, everybody? And because this problem, it just say sketch a possible graph. If you sketch your graph like this, that's okay. That's possible. Okay? So because we don't have any restriction in the middle, so that's like that. Okay, next. We connect this point and with this point, and then when you connect this, the top makes more sense or the bottom makes more sense? The bottom, yeah. So let's go a little bit like this. And then erase the top. Okay, everybody? I put a cross there, it means erase. Because in the notes, I want you to have the thinking process. You start with a pair of dots. Then you decide which one to use. Okay, when you connect them. Decide which one makes more sense. Okay, everybody? Okay. Now it's your turn to do example 5. Okay, less information. Just 5 information. So you should have an easier graph. It's okay. Connect them. You know you can plot horizontal axis. You can plot it. Sense? Good. Show me? Yes. So let's check our answers together. Okay, so f of minus 1 is -2, f of 1 is 2, f of 0 is 0. And then here, x goes to minus infinity equals to -1. So y goes to -1 here. Draw a dashed line to indicate there is a horizontal asymptote. And when x goes to infinity, the y goes to 1. Draw the dashed line here. And then when you connect the point, keep in mind, you can cross horizontal asymptote. So it's okay to go through it and then you're approaching it. Here you go through it and then approaching it. And then you erase the dot here. Erase the dot here. Okay, everybody? Have a nice day. See you on Wednesday. And Wednesday, you need to print out worksheet 3.2. Okay? Bye.